All right, today we're going to continue talking about some trig work, specifically angle measurements using reference angles and coterminal angles. Let's first talk about what these two are. What a reference angle is an acute angle being less than 90 degrees. So we are dealing with angles that are going to be part of an entire circle. They can fall in any of the 360 degrees. But we use reference angles to create triangles. And what a reference angle is it's any angle that starts from the center of our circle and again is acute. So if it lands in the third quadrant, like I'm drawing here, the reference angle is going to be the angle that goes straight up to our x-axis. It's very important that we go back to our x-axis and not our y-axis. One way I remember or I think of these things is kind of like if this was a float. If I put a float underwater, if it's in the third or the fourth quadrant, where would it rise to? So if I had a stick in the water, like you see here, and it had a float at the end, it would immediately go straight up to this pole. Now, if I went to this side, the surface that it would go to is directly up here. And if I were in the first or second quadrant, what it's going to do is just think of it like gravity. Where would it fall? The direction that will fall will be our reference angle. So as we look at this chart here, it's going to show you what you need to do in order to find the reference angle of any given angle. Depending on the quadrant that it falls, if it falls into the first quadrant, what we do is we just take the value, whether that is written in degrees, which you can see the degrees are written in purple, and the radian measurements are written in red. But either one, regardless, if it's in the first quadrant, it just is what the angle is. So 72-degree angle has a reference angle of 72 degrees. If we fall into the second quadrant, these are angles between 90 and 180 degrees. What we will do on degrees is we will take 180 and subtract away the angle measurement. So if I have 125 degrees, I would take my 180 degrees, subtract my 125 degrees, and that would give me my reference angle of 55 degrees. And if we are dealing with radians, what we do is we just take whatever fraction that is, and we go 1 minus that amount, and then we just simply put a pi on at the end. If we fall in the third quadrant, what we will do is we will take the angle measurement for degrees and subtract 180. Remember, in the second quadrant it was 180 minus the angle. This one is the angle minus 180. And then same thing with the radial measurements. We will take the angle measurement and we will subtract 1, and then we would just tack the pi back on to that. And then if it's in the fourth quadrant, what we will do is we will take the angle measurement and subtract it away from 360 if we are in degrees. If we are in radians, we take the value 2 and subtract the angle measurement, and then we simply tack a pi onto the back of that. Now, if we have any angle measurement that is over, if it is over 360 degrees, all we do is we subtract away 360 until we get on this unit circle here that is with 360 degrees. So if I had like an angle measurement that was 750 degrees, what I would need to do is subtract away 360 to get us back into a degree measurement, in which it does actually fall. So when we subtract 360, we are still at 390 degrees, which is still more than 360. So all we simply do is we subtract 360 one more time. So the reference angle that is associated with 750 would be 30 degrees. Since this falls in the first quadrant, we just simply keep the measurement, which is 30 degrees. So that is how we find reference angles. Now the second part of our lesson, we'll go ahead and get our notes out of the way here, are called coterminal angles. Coterminal angles are angles with different rotations, but they have the same initial and terminal sides. And you see below, I have listed for you what an initial side is. That is that degree measurement of 0. And the terminal side is simply where I use the term spinner. You think of like a game, it's where the spinner stops spinning. One thing that I think of whenever I think of a terminal angle is the Price is Right game, where they spin the wheel, and you're trying to get $1. Well, you could spin the wheel and it makes one rotation on being $1, or you can get up there and spin it and it spin 5 or 6 times and lands on $1. Either way, it's $1, but those are coterminal angles because they started at the same place and they finished it, but they had completely different rotations. So those are what coterminal angles are, and then reference angles. We're going to see how to find each of these. So as we look at this, you can see I've got these labeled in radian measurements around these things. The reason why I did radians is because we are usually a little more familiar with the degrees. Like this is 90 degrees, this is 180 degrees, this is 270 degrees, and then of course a full rotation is back to 360 degrees. So what we're going to do when we're trying to find, in this case, we're looking for reference angles. When we're trying to find a reference angle, what we first need to do is find what quadrant the angle falls into. So if we're looking at 390 degrees, that is a rotation of 390 degrees. Its terminal side leaves us in the 4th quadrant. So if we are in the 4th quadrant, we are going to use the formula 360 minus the angle that we have. So that'd be 360 degrees minus 319 degrees, which means the reference angle for a 319 degree angle is 40 degrees. And we just have to follow these guidelines as we do these. Now we are looking at a reference angle that's 240 degrees. Again, this is our 90, 180. We're bigger than that, and then our next angle is 270 degrees. So 242 degrees falls between 180 and 270. So we are in the third quadrant, excuse me. We are in the 3rd quadrant. So from here, our rotation will put us in that 3rd quadrant. We are dealing with degrees, so our degree measurement is going to be the angle measurement, 242, minus 180 degrees, which gives us a reference angle of 62 degrees. And that is an acute angle, so that would be our reference angle. As we look at this one, we're going to convert a radian measurement and find the reference angle to this radian measurement. So what we'll do is this. It's sometimes hard to tell what the fractions are, so we're going to convert this to a decimal. And what we need to recognize on this decimal, just like any rotation that goes over 360 degrees, we oftentimes have to remove that. But what we've got to remember is when we're talking about a full rotation for radians, that is 2 pi. So if this number is higher than 2, we will do this. So what I put in my calculator is 32 divided by 9. If your reference angle has a negative sign, you can ignore this rotation. They will be in different places, but they will always be the same distance from the x-axis. So we don't need to worry about this. So when I put this in my calculator, what I get is 3.5, 55556, so 3.5 repeated is what we end up getting here. So what I'm going to do, since this is more than a full rotation, I need to get rid of that full rotation. So that full rotation is minus 2. So what I end up with is 1.5 repeated. So I've already got this in my calculator, so here's what I'm going to do. I'm going to subtract the 2 away, and it's 1.5 repeated, and I'm going to use my calculator and go math, enter, enter, which is the fraction mode. So I'm going to keep this number in mind because I do need to reference that. But when I convert this, this ends up being 14 over 9. And then, of course, that's pi. So the reason why I wanted to keep this value here is because I will use this value to determine which one I'm going to use. So you can see these are labeled for radians, half radians, 1 pi radian, and then 1.5. So this is 1.55, so it's actually just slightly, very slightly above the 270-degree measurement, but it's still in the fourth quadrant. So if we're in the fourth quadrant, what we're going to use is in this case, the red symbols, and the red symbols say to take 2 minus our measurement. Now, it's not the original measurement, it's the measurement that we see here. So we will do 2 minus 14/9. So 2 minus our value 14/9. It actually gives me 0.4 repeated. Anytime you have a repeated value, in this case it ends up being 0.4. That's 4 divided by 9. If you don't know that, you just go math, enter, which is again your fraction, fraction mode. So this ends up being 4/9. And then what we do on this formula is we just go back in and tack our pi on. So these are a little less common, and we are also a lot less familiar with this because we don't deal with radian measurements nearly as much as we do degrees. But this is how we do it. Remember, if the number gets above 2, we just subtract 2 until it gets where we need it to be. Now we're going to take a look at kind of a little different thing, which is finding different angles that have the same reference angle. Now notice this on our left side here. It tells us we are dealing with angles between 0 and 360 degrees. That's basically saying we are limiting this to one rotation. We're not going to go beyond rotation because that's the thing about circles. They are infinite. So we could sit there and rotate it all day and find these reference angles. Now if we're staying inside of 360 degrees, that means there are 4 angles that have the same reference angle. So what we're going to first do is figure out what is the reference angle for an angle that is 152 degrees. So if we're talking about 152 degrees, that puts us into the second quadrant. So if we're looking for the second quadrant, what we need to do is take 180 and subtract our angle measurement, which in this case is 152. So our reference angle is going to be 28 degrees. So remember, reference angles always fall into the first, so obviously the 28 degrees is going to have the 28 degree reference angle, and then 152 will be our angle in the second quadrant that is going to be have a reference angle of 28. So let's talk about the third quadrant, which is our quadrant right here. 22 degrees means we will be 22 degrees away from the current spot right here. So if we were to draw this angle, it would look something like that. That's about 28 degrees. But this is 28 degrees beyond 180 degrees. So if we wanted to find this reference angle, we would add the 28 degrees that we know to the 180, and this would give us a 208 degree angle. So the angle in the third quadrant would be a 208 degree angle measurement. And then lastly would be the angle measurement that would fall into the fourth quadrant right here. And it would be 28 degrees away from our x-axis. So it's going to be 28 degrees short of 360. So the reference angle would be 360 minus 28 degrees. And that puts us at an angle measurement of 332. So these would be the reference angles that are the angles that have the same reference angle as 152. All right, and the last thing we're going to take a look at is our coterminal angles. So coterminal angles, like we said, are angles that are in the same spot. If I were to spin this spinner, these angle measurements would be on exactly the same location. Now this actually, every angle has an infinite number of coterminal angles because it could rotate one more time. And then we could rotate one more time and rotate one more time. Here's what we need to pay attention to though. We are looking for a coterminal angle where the angle measurement is between 0 and 360 degrees. So we have an angle measurement that is at negative 1008. So we have rotated clockwise from 0, so 1000, we're going to keep rotating just like you see me doing there. What we do if we're looking for a coterminal angle is we simply just add 360 until we find, till we fall in the range that we are given. So if I'm at negative 1008 degrees, what I'm going to do is simply keep adding in this case. If the number is large, like a positive number, you subtract 360 until you fall between the range that they gave you. So what we're going to do is we're going to add 360, which is a full rotation. So if we add 360 to this amount, we are now at a coterminal angle that is negative 648. These two angles are coterminal. They are coterminal angles, but the angle 684 does not fall in the range that they wanted me to be in. So I'm going to add another 360. This takes me to negative 288. Again, this is a coterminal angle, but it is not the coterminal angle that they are looking for. So we add 360 one more time. And when we add 360, we are now at 72 degrees. And 72 degrees is between 0 and 360. So this is the coterminal angle that they were looking for. Notice I said the coterminal angle because all of the angles we passed along the way are coterminal. These are all coterminal angles. And I could keep adding 360 and keep creating more and more coterminal angles, but they only wanted the one that falls in this range between 0 and 360. So when you think about coterminal, just think about removing a rotation or creating a rotation until you fall in the appropriate range. All right, you have a Delta Math. You've already done several of your assignments. Good luck.